All right. Good afternoon, everyone. And welcome to this session about using domain-driven design in .NET project and experiences from that. My name is Per Ruvegård, and I will entertain you for the next hour and 15 minutes. I refer to myself as a software developer and a software architect. I blog occasionally at programmaticallyspeaking.com. I tweet occasionally. You have my handle up there. I have a PhD in software engineering from Blekinge Institute of Technology in Sweden, and I work as a consultant at Factor 10, which is a Swedish company. Now, the main message I have for you this afternoon is dare to challenge development habits. And I hope it will become clear during the presentation what I mean with that. I don't mean change your keyboard layout to Dvorak instead of QWERTY, although you might want to do that for other reasons. I also don't mean do everything different, because when we do software development, there are certain constraints that we need to take into account. So let's talk about those. I think about constraints of two types. There are negative constraints and positive constraints. And as usual, it's most interesting to talk about the negative stuff, so let's start by doing that. When I thought about which negative constraints we have when we were doing software development, I thought about standard approaches. We have a problem. We're going to create some software to address a specific problem. Let's use standard approaches. Let's use the same solutions as we always do, how we've always done it. I think this is a negative constraint because I don't think that is a good approach. Just like being in your comfort zone is also a negative constraint. If you're in your comfort zone and you use standard approaches, then you won't get any creative new insights and you won't improve and learn new things. Another thing I see a lot is just-in-case development. We have a problem and we try to anticipate what it will look like some time from now, and we write a lot of code just in case we will need it. And this is sort of direct opposite to well-known principles such as YAGNI, you ain't gonna need it, and KISS, keep it simple, stupid. Another negative constraint which is very interesting is enterprise has to be big. And while most enterprise systems are big, I think if you look at the individual parts of an enterprise system and the constituents that make up the enterprise system, they don't have to be big just because the enterprise is big. We can use simple solutions to solve problems even though the enterprise in itself is big. So when I say challenge development habits, I mean challenge these, don't play it safe, try out new things, and try to sort of challenge yourself. Then there are positive constraints, which I think we need to not challenge. These are, for example, your current knowledge level. So if you know very little about something, a domain, then of course you should use solutions and approaches that are based on the fact that you know very little. Whereas if you know very much about the domain, then of course go ahead and use solutions according to that. We have domain characteristics. Are you in the telecom industry, finance, government, and so on? Then those domains have characteristics that we need to play with. And the most important thing of all, customer business value. We need to provide high value to our customers, and that is something we can't really toy with. So challenge the ones on the left, but don't challenge the ones to the right. So the title of the talk says experiences, and I have some experiences to share from a project. So the story involves a big client with a big enterprise system. And sadly, the client had a problem because the code was not in control. And with code not in control, I mean that it was too big, too much code, more code than was necessary to solve the problem. And the developers were struggling to keep the system floating, to fix bugs and make everything work properly. Have you heard about this phenomenon? Yes. This is not unusual. We see this a lot. It's a very common problem. And another thing that I think is common as well is that they were in the process of replacing an old system. So they had this old system with its roots in the 80s, I think, with an old architecture, and they were moving pieces of functionality, or migrating functionality, if you wish, into the new system with a new architecture. And the story is essentially, and what we did is that we built a piece of the new system, we took some functionality from the old system and migrated that to the new system. That is what I'm going to talk about. Now, if the client had done this themselves, they would have used their normal approach. And they would have built a system with a number of layers, perhaps 10, give or take a few. And they would use a very conventional OR mapping. So they had a Microsoft SQL Server, and they would use an OR mapper called nhibernate. They would separate the client from the server and have a UI separate from the server, and they would communicate with the WCF service. And the server to UI would be a one-to-one mapping, so the service was private, and the only consumer of the service would be the UI. And then the subsystem, it's not in the picture, would expose other services for different subsystems to communicate with. This was a very database-driven system, but it wasn't. I mean, sometimes database-driven is the correct choice. In this case, it wasn't. It wasn't good that it was database-driven. They had a very heavy service layer, so instead of having a model-centric system, they had a lot of business rules and business logic and interesting stuff tucked into a service layer. I suppose you have heard of that as well. Anyone recognizes this? Yeah. And on top of that, and because of that, there were a number of problems that we wanted to avoid. So instead of building the new system, using the standard approach that the client would use, we decided that we wanted to avoid some of the problems that the client was facing. These problems were a lot of uninteresting layers, I said 10, give or take a few. If you have many layers, that drives size, right? Because you will have to write a lot of code that is responsible for just shuffling data back and forth between layers. They also had a number of uninteresting model transformations. So to get data up to the UI, they would read data from the database and get a data set, and then the OR mapper would transform that into entities, and then they would have a layer that transformed the entities back into a data set and pushed that to the UI. And that also led to an explosion in size. They had a very weak partitioning, so they had multiple subsystems sort of that made up their entire system. And while on paper they were partitioned very nicely, when you looked at how they communicated with each other, you saw that that wasn't really the case. And especially if you opened the lid to the database, you would see that all the subsystems shared all data in a database. They would go into each other's tables and pick data, write data, read data. So while the client would say that, well, we should be able to move a subsystem onto a different database server on a different database, that was really not possible because all the subsystems, they used each other's data. As I mentioned, they had a very heavy service layer, so they would put business rules and business logic in the service layer, among other places. It was very scattered. And they would have very few automated tests, and I would say as a result of their choice of architecture, because the architecture that they were used to build a system with didn't really lend itself well to testing. It was very difficult to test things. So that meant that they had a lot of manual testing. After a release, people would spend weeks and weeks, in one case a whole summer, to test the system because it was very uncertain whether or not it was good. And it was dangerous to change anything. A tiny little change in one place could ripple through the entire system and cause unforeseen side effects, and they would not have any chance of detecting that until it was too late. So, of course, we wanted to avoid all of this. What we wanted to do was to have few layers, and I'm not going to mention a number, but we wanted to have a few layers as possible, or as needed, actually. As few as we could get away with. We wanted it to be tiny, so instead of having a big complex architecture, multiple layers, a lot of code transforming models, we wanted this to be very tiny with as little code as possible. And we wanted this to be model-centric. We wanted to focus on the model. We wanted to move logic and business rules, interesting stuff, into a model that could be interacted with, instead of having it in a service layer where it was hard to test. We wanted to use the same model across the system, from the UI to the storage, instead of having different models and transform between these. We wanted to have strict partitioning so that the subsystem that we built, if someone would take a look at it on paper and say, well, it looks nice on paper, but can I really move it to a separate database server, to a separate server altogether? The answer should be yes. It should be very neatly partitioned. We chose to use the same basic technologies as usual. We kept the distinction between the UI and the server. We used WCF for communication. We used the same database server, but we ditched the OR mapper. So instead of having that, we chose to just persist an object graph. And I will talk a little bit about that later on. Now, how did we do this? Oh, and one thing more. We wanted this to be very well tested, of course. How did we do this? Well, we didn't do this, of course, by using the ordinary way, the habitual way, in which we would have been very much database-driven. If the client would have done this, it would have been, that's supposed to represent some messy explosion or something. We wanted to challenge the habits of the client. We wanted to use domain-driven design, and we wanted to arrive at something star-like. That was our intention. In this talk, I will talk about different topics and patterns in domain-driven design that enabled us to build this system and how we use these patterns. And the first that I'm going to talk about is the domain model. What is a domain model? Well, it's not just a data model. It's not just an object model. It's something more. So if we have a problem domain, then that problem domain is full of interesting stuff. There are entities, there are rules, language, behavior, a lot of stuff that is really something that we want to capture. And the way to capture those interesting aspects of a problem domain is to use a domain model. So the domain model captures all that. So it's more than, in the sense, the data model and the object model. And one very important aspect of a domain model is that it has sort of semantic operations. So it's not about data access. Domain-driven design is not about data access. It's about showing intent. As an example, consider the following code. We have an account, and that account has a balance. And the first operation on top says account.balance minus equals 50. So we subtract 50 from the balance. And what does that mean? Well, it could mean anything. The second is semantic. It shows intent. It says that we have an account, we withdraw something from the account. And note that I didn't put withdraw 50, because I chose to make explicit the currency that we withdraw from the account. I mean, on top, it's implicit. Is it by default dollars in our system? What if we want to withdraw some other currency? Then we would have to convert that to dollars. But the second form, we have, in fact, some way of expressing that 50 is a dollars amount. And it could be some other currency as well. So by using sort of a different way of interacting with the model, we can show our intent much better. So taking one step back, then, what is a model? So I found this really nice picture on Flickr. It is a tree. So let this represent our reality, our domain. Now, there are a lot of interesting stuff here. The tree has leaves, a trunk, there is grass and a shadow and a stone. And in the back, you see water and a stone bench, and there's land. I mean, a lot of interesting stuff. Now, I wanted to create a model from this reality. And this is what I came up with. Would you agree that this is a model of the reality? So if I showed you the thing to the right, I drew it, not my kids, actually. So if I showed this to you, would you conclude that what I'm trying to model is probably a tree, right? I hope you would say that. Sorry? Mushroom. But as you can see, they are quite different, right? The model and the reality, or in our case, the domain, are quite different. I chose to make the model represent the fact that we have a tree, but I left out a number of things. So while I have the leaves, the trunk, the ground, and the grass, I don't have the water in the back. There's no shadow. There's no little stone. And I don't capture the fact that the tree leans to the right. So I only chose to model relevant aspects of the domain. I chose to model enough to communicate the fact that we have a tree. The model won't have all the details because it doesn't need them. Let's say that we have a problem that we need to solve. We create a model that only has enough details, only captures as much as is necessary to solve that problem. Everything else is essentially, or at the moment, not relevant. So, when it comes to a domain model, then, there is the same relationship, right? We have our problem domain, and we create a domain model, and it captures enough to solve a problem. It models a relevant aspect of the domain. And in relation to that, there is a very important concept in domain-driven design called a bounded context. Because when we create a domain model, it applies within something called a bounded context. The bounded context is what sort of where we draw a line around our domain model, and we say that within this bounded context, we create a model of the domain for a specific aspect of the domain and to solve a specific problem within this context. So my model of the tree would apply within one bounded context. But in another bounded context, I would probably need a different picture of the tree. In an enterprise, typical enterprise system, there will be multiple bounded contexts. You can have multiple subsystems. And for example, each of those subsystems could have its own bounded context. And if you have multiple bounded contexts, then you have multiple domain models, right? And these domain models will be different because they will model different aspects of your domain. So one bounded context could be about ordering, and another bounded context about inventory. And if you look at the domain models for ordering and inventory, they will not be the same. So instead of trying to create a domain model that spans the entire domain and the entire enterprise, which most likely will result in a failure, you recognize that there are multiple bounded contexts, and you create specialized domain models for these contexts. So if you went to my colleague Jimmy's presentation this morning, he mentioned client as an example. I mean, in an enterprise, you will have the client concept in a lot of places. But if you look in these different bounded contexts, client can be in both domain models, But since we're in different contexts, it can mean slightly different things in different places, because we model different aspects. Now, DDD, domain-driven design, is very model-centric. You should focus on the domain model. The domain model is the heart of your business. This is where you capture everything that is relevant about your business. This is where you get value for your investments, or your return on your investments, and this is what will sort of endure. There must be a balance. So, of course, if you focus a lot on the domain model, you will, focus less on something else. It's important to not forget the user interface. You must let the customer try what you have built, and the user interface is an excellent way of driving the development of a domain model, because it lets you find new use cases, and through those, revise the model over time. And in the story then, when we built this subsystem for the client, we actually gave the UI too little attention initially. So we were so eager to focus on the domain model to sort of do it differently than they would do otherwise, that we didn't forget the UI, but we paid too little attention to it. On the other hand, once we recognized this, we had a rich domain model, and it was very easy to build a UI from it. Now, talking about the story and the client, and how they would do and what we didn't do, I listed some contrasts here. So one thing that you might have read about, I hope you haven't practiced it, is big upfront design. Do you know about it? Yeah? So they would sit down at the beginning of a project, and they would draw a big model, and they would try to anticipate everything that could happen and everything that they needed to know, so they would speculate a lot, speculative modeling. They would create a data model, and from that they would derive an object model, essentially. So when we compared their object models and data models, they were very much one-to-one. And as I said, they would put their domain rules and their logic mostly in a service layer. So what remained of the model, the object model, was mostly data objects, which makes sense because it sort of was derived from the data model. This is known as an anemic domain model, a domain model that is sort of empty of all the interesting things that you find in the problem domain, rules and logic, constraints, and so on. So instead of this, we chose to do incremental modeling, or perhaps it should be iterative modeling, to refactor the model as we learn more. So instead of creating something big when the project started, we created something little that reflected the knowledge we had at the time. Then during the project, we would learn more, and we would refactor the model, and let it grow. This is in domain-driven design lingo known as knowledge crunching, where you constantly look at what you have, and you question your domain model. Does it really fit? And if you see that it doesn't really fit, you try to change it to fit so that it fits better. And you come up with something revised, improved, that is much better. Knowledge crunching. We also said that let's put the domain model at the heart of everything. Let's make sure that the domain model sort of goes through the entire system, instead of having multiple different models that we would transform between. I think of this as extreme domain model focus, because really, how many models do you need? Typically, you would have a data model, and you would have a domain model or object model, perhaps. You would have a view model, and when you transfer things on the network, you probably have models there as well for representing the data when it goes over the net. There can be a number of models in your system. And if we relate that to what I said before, that we start out with a small model, and through knowledge crunching, we let it grow as we learn more, then of course, if we have multiple models, then we would have a hard time keeping all those models in sync. Because every time we refactor the domain model, we will have to refactor the data model, the view model, and everything must click together. So by letting the domain model permeate the system, we can avoid the uninteresting model transformations. Now, I'm not saying here that you should never ever create other models. What I'm saying is that you should defer creating the other models until you need them. If you need a separate view model, and you probably need some view objects in the UI, but perhaps not mechanically create a view model that is a more or less one-to-one mapping to your domain model. Perhaps you can even use some objects from your domain model and bind in the UI. And then just a few view objects to complement that. So I'm going to talk about 2 examples. What we did when we created this system. So first of all, we said, let's have the domain model in the UI. And the problem we tried to address was this that I talked about before, the dataset shuffling. So as I said, the data would be read up from the database, and then the OR mapper would convert it into entities in their anemic domain model, and then they would have a layer that translated that into a dataset again and pushed it to the UI. And we found that this had very bad performance, and it was very error-prone, because that was a lot of code that had to be written. And you know, coding against datasets is not a very good programming model. So we said, all right, to do something different, to challenge this habit, let's shuffle domain model objects. And the reason we said this is okay is because the WCF communication between the server and the UI was sort of a private link or private line. The only consumer of that service would be the UI and no other client. So it wasn't the case that we sort of exposed the domain model to other systems. It was sort of within the system still. And that allowed us to have a rich domain model interaction in the UI instead of interacting with datasets. And we could also have a custom data binding and bind to parts of the domain model directly in the UI and have as little model transformations as possible. The second thing we did was that we said, let's put the domain model in the database and not have a separate data model. So the database the client had was a low-performant and very inflexible database. Everything was connected to everything else. I suppose it's quite common. It sort of organically grew into this, of course. The partitioning was extremely weak, as I said before. If you looked at 2 different subsystems, they could go into each other's tables and take data. And also what the client found that when they really scrutinized their mappings, they saw that, well, that subsystem, it interprets this column in this way, and that subsystem interprets this in a totally different way. There was sort of a mismatch between how the data was used. So the subsystems were really stepping on each other's toes, right? So we said, let's just serialize the object graph. Let's build sort of a NoSQL solution within Microsoft SQL Server. So we used the same database technology that they already had. And just serialize it and be done with it. And this led us to have a very strict partitioning as well, because the result was, of course, that no other subsystem could go into our tables and mess around with them. Because sort of, you know, it was not visible to them what the format of the data. And the result from this was that we had extremely low ceremony. Do you know what ceremony code is? So when you have to write a lot of code to, for example, transform between models, to shuffle data back and forth, glue code and stuff like that, code that you just have to write, but it doesn't do anything interesting. So we could keep that down to a minimum. And since we used sort of the domain model everywhere, we could get rid of or have minimal context switching for the developers. I think one of the reasons that you have a data model and that sort of influences your object model is that we are not really good at mentally thinking about different models that are sort of tailored for their purpose and thus should look different. So we want to sort of make them all look the same. And thus we end up with an object model that is a copy of the data model. We had a very simple UI data binding. We benchmarked and we found out that the database performance was excellent compared to what the client was used to see. All right. So the next thing I thought I'd talk about is domain-driven design patterns. And domain-driven design patterns come in two flavors. There are strategic patterns, and I talked about one of those, the bounded context. The bounded context pattern sort of affects your entire architecture on a very high level. It can affect your organization even, because you can say that in different bounded contexts, I have different teams working. But then there are tactical patterns, and tactical patterns are more hands-on, affecting your domain model. Before talking about the patterns, I thought I'd mention two anti-patterns. First, we have this. When we looked at subsystems that the client would usually build, we saw that all the objects in the object model were sort of reachable through a root object. So once we got hold of the root object, we could traverse the entire model just by association, by dotting us into the model. So for example, it could be, we have a company, let's get the customers from that, the first customer, let's get the orders, the last order, the order items, and sum over those, right? And as one developer expressed, this is very convenient. I have IntelliSense, I can just go through the entire domain model. But it wasn't very practical. To make this practical, you have to sort of tie this very close to the storage mechanism. You would have to let the OR mapper lazy load data. So for example, once you hit the customers collection, the OR mapper will detect that and go ahead and load the customers from the database, and then you have them, and then it will load orders and so on. So you tie the storage and the model together very much. And if you look at the model, you will see that all the objects are first class. All the objects are identifiable with an ID, which is, I suppose, a result of it being sort of a data model replica. And it's unclear what should be loaded and saved together. If you look at the domain model, you don't really see any clear boundaries where you should treat things together. So this, of course, gives a very, very high flexibility. You can just pick any object in the model, interact with it, load it, interact with it, save it. The problem is that it's very difficult to enforce rules. How do you know that you're not sidestepping any rules if you can arbitrarily take any object in the model and just do anything you want with it? As a result, of course, it's best to wrap everything you do, just wrap it in transactions, to make sure that everything, just to be sure to make sure that you don't violate any principles, right? So domain-driven design has one tactical pattern that is a remedy for this, that we can use to avoid these anti-patterns. It's called an aggregate. And as the name suggests, an aggregate is something that consists of other things. So you have several objects in an aggregate, typically. You have identifiable entities and something called value objects. And if you look at an aggregate, it can only be identified through its root, its aggregate root. Which means that what's within the aggregate can only be reached through the root. You can't arbitrarily go into an aggregate and say, I want to interact with that object. You need to ask the aggregate root, once you have it, how can I interact with this aggregate? So it's sort of a protection around functionality objects that go together. And we say that when we have an aggregate, it needs to be internally consistent. So we persist it as a whole, we wrap it in a transactional boundary so that internally it's always consistent. And then when we look at other aggregates, we say that we have eventual consistency. So if we want to save two aggregates, we save one and it fails, and then we have to do something else to recover from that situation. But the one we managed to save, that one is consistent. So what is a value object then? Well, a value object is something that doesn't have an identity. It's an object that is defined by logic and data, which means that you have two objects and they have the same data, they can be treated as if they were the same. There's no way to distinguish between them because they are the same. And this is actually a great thing. Make sure to keep them immutable. An immutable object is an object that where you cannot change the internal state of the object. If you could, that would be very dangerous, because if you had two value objects and say that these are the same, and then all of a sudden someone changes the internal state of the second, then of course they are not the same anymore. And you cannot really treat them as easily. Because if you have immutable objects, one thing you can do is you can share them between threads. Immutable objects are automatically thread safe, for example. So, do you know about any value objects in the .NET framework? Point? And anything else? String is good. String is immutable. Datetime is immutable. So when we deal with these value objects, we should only allow side effect-free operations. And what that means is that when we do an operation sort of to change anything on a value object, we don't change the value object, we create a new value object. So consider datetime. If you have datetime.now, which is globally available object, and you want to say that I want to have the time that is now and 5 minutes in the future. You say datetime.now.add minutes 5. And you don't change now, right? That would have very interesting side effects. Instead, what you get is a new datetime object that represents the time now plus 5 minutes. And the same with strings. You can't really go in and say, I want to change the 5th character of a string to something else. You would have to get the character array, change it, and create a new string from that. And these are great properties of value object because it allows us to handle them quite carelessly. If we ask an aggregate root, can you give me, your value objects? The aggregate root can hand them out and know that the receiver have no abilities to mess things up, which is great. Now, in .NET, we have structs. And structs have value-based equality by default, which means that if you have a struct like point or anything else, they will be sort of value objects by default, and you can by default compare them if they have the same data. They will be the same. There are things to look out for. For example, if you look at a system.valueType, which any struct will automatically inherit from, in reflector or .peak, you will see that the quality comparison are based on reflection. So there might be a performance hit if you have a big value object. But, it's easy enough to create your own equals and hash code. And there are, of course, value type semantics, allocation on the stack instead of a heap, and so on and so on. But it's a good starting point for creating value objects. Now, aggregate design is not something that is easy. It's very difficult to get it right. But so while it requires some effort, when you succeed in it, you get very clean separation of concerns in the model, which is great. And we found that the property of an aggregate that it should be internally consistent is actually a good driver for sort of getting your aggregate design right. Because if you think that here are two objects and they must be sort of consistent with each other at all times, well, then probably they should go in the same aggregate. Whereas if you say that I have two objects and they will change independently of each other, one change here has no effect whatsoever over here, well, then they can probably be in different aggregates. Another good driver is load eagerly. So instead of relying on an Aura mapper to lazy load everything, let's just load the entire aggregate in one piece. And if your response to that is, well, I can't do that because then I will load too much data. It will be too expensive. Well, then perhaps your aggregate is too big, and you should try to slim it down a little bit. Now, since we partition our domain model in this way, or sort of divide it into pieces, then of course the associative travel I talked about before is only possible within one aggregate. And of course only to the extent that your aggregate root permits you. So once you have your aggregate root instance, you can ask it for various things, and it can let you get to the certain inner details of the aggregate. But of course you will reach sort of the boundary at some point and say that, well, now I can't get from the company, I can't get my customers. Or I have a customer and I can't get the orders. So what do you do? Well, when you do the design in this way, you end up with a very loose coupling between aggregates. And one way is to just say, I have my aggregate instance. It has an ID which points to an instance of a different aggregate. And then when the client finds that ID, it has to go and look up another different aggregate instance through the ID. And by having this loose coupling, we can do a lot of, different modeling, things with the model that we ordinarily wouldn't do. So when I talk to the client about this, a typical thing that we see is that we have sort of a parent object, and we say to the parent object, give me the children. And you saw that before, company, customers, and so on. That's a quite common problem. But if you have loose coupling, you are free to sort of to explore the possibilities of reversing the relationships between aggregates. So instead of saying that a parent, I reach customers through a company, then perhaps I reach customers, the children point to the company. So I had this discussion with the client. We were talking. This was not a domain with projects and owners, but for the sake of talking about it here, I changed it. So I was looking at their design, and they had this object that didn't have a good aggregate design. And they had this object project, and it had a list of owners. And I thought that was a bit peculiar. So I asked them, does the project really need that list? Because when I looked at the code was always doing project.owners.first or get index 0 everywhere. And the response was, well, there can only ever be a single owner for a project. I mean, that's the domain. But what if that changes? We don't need it. We want to safeguard against any changes. So they were doing just-in-case development. So I said to them, let's just decouple project and owner and try to reverse the dependency and say that instead of reaching owners through the project, we treat them as separate aggregates and say that we get the owners for our project. So we let the owners point to our project. And by doing that, the question of having one owner or multiple owners in the future, if that should change, it isn't really a problem anymore. We use a separate repository for owners, and we get owners through that repository. So what is a repository then? Well, a repository is a different DDD pattern. It's an abstraction of a collection of instances of an aggregate. And if we have projects and we have owners, project objects and project owners, then, owner objects, then we have different repositories. So we have one repository for loading projects, and we have another repository for loading owners. And a repository provides operation not only for loading, but also for saving instances. And just with anything in the domain model, as I said before, we want to have semantic operations. So instead of having something where we just get everything by ID, and we have generic operations for everything, we want our repositories to capture the intent we have when we load data. So when getting owners for a project, well, we have a method that says get owners for a project, and you can imagine that we would have more methods where we say get owners of a certain type, and so on and so on. So not generic, but methods that capture the intent of what we want to do. So when we built this subsystem, we used all these patterns quite successfully and ended up with a domain model that was quite unlike what the client had before, where we had a good aggregate separation of concerns in the model. Now, the next thing I want to talk about is simple solutions. And what is a simple solution then? Well, what the client had was essentially the same architecture in all subsystems. So they would say that this is our one-size-fits-all architecture. Regardless of the type of the subsystem, if it was a big subsystem with a complex aspect of the domain, or a small subsystem with a sort of simple aspect of the domain, they would use the same architecture. One argument they used was the recognition argument. Do you know about that? If we use the same architecture everywhere, then all the developers will recognize everything. So it's the safest thing to do, right? I don't like that argument, because what we're saying is that we ignore the problem and we just, have a solution, and we apply that solution everywhere so that the developers can, be a bit lazy and not have to care about things being different in different subsystems. Simple solutions as opposed to doing template-driven development. Template-driven development to me means that you, for example, have this big architecture, you use it everywhere, and you have a lot of templates associated with the architecture. It can be a lot of code. One developer I talked to said that, well, not now, but before, we used to create a new subsystem, but just copying the old Visual Studio solution and pasting it somewhere else. Then we had a new subsystem based on the old template. And this typically leads to low understanding among developers, right? So the developers, they don't have to understand very much about the systems they're building, because they can just copy and paste what exists somewhere else. And I mean, that could work for a while, but as soon as there are problems and they need to find bugs, they know very little about how to fix them. A better approach is, of course, to be need-driven, to say that we need very little in the beginning, so let's start simple and start with very little. And then when we need more, we sort of step up and use different things. Another thing that goes against simple solution is starting out with big complex frameworks, which I see a lot everywhere. The problem with big complex frameworks is that they're often very opinionated. And an opinionated framework means that it will sort of affect and influence how you build your system. It will influence your architecture, perhaps even dictate how you build your system. I don't like that very much. I like it much better when I dictate how I build my system and not a framework. And you will get lock-in, probably, meaning that some time from now, when you decide that, well, I don't really need this framework anymore, then all your code is really sort of tied closely together to the framework, and you're sort of in a bad position. So why do you think we end up with big complex systems? Why don't we have simple solutions and simple systems everywhere? Well, I think one issue, perhaps not the core issue, but at least one core issue, is number of developers. If I develop software, I would like to have few developers. And with few developers, you get by with very simple structures. You don't need very complex things because it's easy to manage if you're 2, 3, or 4 in a team. Simple code, high productivity. Anyone that has ever encountered merges from hell? In a place I used to work in, a colleague told me that once they sort of wanted to merge their code, they would have to dedicate a week for the merge. No joke. And then a month later, they would have to dedicate a week to merge back their code that a different team had merged away, right? So if you have many developers, that often sort of leads to complex structures. It tends to grow complex structure out of having many developers. Many developers drives size and complexity. And the reasons are that you want to be able to work in parallel, and you want to be able to work in different parts of the system, And while that's nice in theory, I have never really seen it work in practice. Because even if you think you can do this, you end up stepping on each other's toes. So let's talk about knowledge for a while. This is something that I think is very interesting. And I think we tend to sort of not deal with this when we develop software. So I have here a graph. It represents the knowledge during a project. In the beginning of the project, we have very little knowledge, and I'm thinking about domain knowledge here. We have very little domain knowledge. This is like typical for most of the projects I've been in. I start out with a sort of blank sheet. And as the time goes by, I learn more and more, and towards the end of the project, I will probably know a fair amount. And my point here related to simple solutions is that we must choose the solutions that match our current knowledge level, and then step up when that is the right thing to do. So for example, this is my only cloud picture. When we know much about the domain, then we can choose, sophisticated, capable solutions in the cloud and with many sides, and But when we're in the beginning of our project, we need simpler solutions, simple circles and triangles and squares that match what we know. And as you can see here, what happened during this project was that we ended up replacing the simple solutions with more, perhaps capable solutions, more sophisticated ones. But there was one solution that didn't survive, the green moon. I don't know what that is, but for some reason, it didn't fit anymore, it wasn't relevant, it wasn't necessary, so we got rid of it. And of course, it's nice that it was a simple solution. We didn't spend much time or effort into creating that simple solution, so that once we got rid of it, we hadn't wasted much time and effort. But if we would have started with the solutions to the right and said at some later point, well, we don't need this anymore, then we would have invested probably a lot of time in it. And unfortunately, this is something I see a lot, that we disregard the fact that we have a sort of a learning, increased knowledge here, and we start with solutions to the right. And that can be for at least two reasons. It can be because we know about these solutions. They are our standard approaches. When we use them, we are in our comfort zone. But it can also be that, as developers, it's cool to use these solutions. It's cool. It's fun to use some cloud solution, I suppose. So we end up doing that. Now, learning during a project, luckily, we have something that I think you all use. Iterative development, agile development, allows us to learn during a project. So we start small, and in iterations, we revise what we have and see if we need something else, and we change. I like to think about the solutions to the left, the simple solutions, as focus-shifting solutions. Because if we relate this to domain-driven design, in the beginning of the project, use simple solutions that allow you to shift the focus to the domain model. Because in the beginning of a project, the problems that are most important, most relevant, are the domain problems, not the mechanisms, not the technical stuff. I suppose you're all very good at the technical stuff. So the technical stuff can always be sorted out later. The domain stuff is what's really interesting in the beginning. It's also about customer satisfaction. Let's say that you have, after one iteration, you have built something and you go to the customer to show it. I'd rather show some working functionality than some mechanism I built. Look at my cool storage solution, instead of having something that the customer feels give them value. And in the end of the project, you can, of course, attend to these technical issues. And one thing that we've found when we built this subsystem was that the simple solutions that we used, they fared very well. So in the end of the project, they sort of were still around. There were no really motivation for changing them. Being simple, they were also very robust and easy to maintain, easy to deal with. So our approach essentially, start with almost no layers, and create layers based on need. So I'm not saying that layers are bad. I'm just saying that each layer needs to do something interesting, and you need to be able to justify the existence of a layer. The client had a lot of big in-house frameworks, a UI framework, and everyone agreed that this was very bloated. So we said, let's not use that. I mean, by habit, everyone would use the UI framework and every other framework that the client had. We said, let's not do that, because we probably don't need it. And what happened was that we only took what we needed, very few pieces, and when it came to all the templates and stuff that the client had, we didn't need anything at all of that. All right, so the next thing that I want to talk about is collaboration with domain experts. This is one of the cornerstones of domain-driven design. And what the client typically would have was some initial collaboration with domain experts. So the developers in the beginning of a project would sit down with the domain experts and talk about what they were going to do. And then the domain experts would go away to other projects and do other stuff. And then the developers were left alone sort of for the rest of the project. The result was, of course, that the domain experts and the requirements people and sort of the receiver of the system, they had very low trust, a very low confidence when it came to the quality of the system. We also found that among the developers, few of them had good domain understanding, many of them didn't. Since they only had this initial collaboration, the developers really didn't know much about the domain. Now, do you need developers that know much about the domain? Yes, you do, of course. We have something, if you were at my colleague Jimmy's presentation this morning, he talked about something that we call the T model. And the T model has, the T has two bars. The horizontal bar that represents business understanding, and the vertical bar that represents technical depth. And these are two very important components that you need when you do domain-driven design. So for a developer to be sort of excellent and to excel at domain-driven design, he or she needs to have technical depth and need to understand business values to be able to communicate successfully with domain experts, right? So what does it mean and what happens when you do domain expert collaboration? Well, if you involve domain experts early and throughout the project, you put the domain experts together with the developers and let them talk to each other. That has a very positive effect on the knowledge. I showed you before the knowledge graph. And what happens is that developers learn about the domain. When they talk to the domain experts, they get new knowledge, and they can use that knowledge and incorporate that into the domain model. And in that way, create a better model that better represents the domain. But it's also the case that the domain experts, they of course start out much higher in the level of knowledge. They will also have an increase in knowledge level. Because as they talk to the developers, through questions and interaction, they will sort of refresh their domain knowledge and learn new things. And what also happens is that we get new insights, things about the domain that we didn't really realize before. And when we get new insights, we can adjust our model to better reflect the reality, right? So what we did was essentially involve the domain experts throughout the project. We did a lot of knowledge crunching. We sat down with the domain expert. We had questions. We had a lot of hypotheses, and we tested those. And the domain expert really participated in every discussions about the model that we had. We also let the domain expert participate in prioritizing features, so we could start by capturing essential parts of the domain, build a model based on that, and then we wouldn't do anything more until we had discussed this with the domain experts. That would be sort of an incentive for the domain expert to really get involved in the project, to see it grow from something very small to the finished system. Do you know who a domain expert is? Are you domain experts? Some areas. So domain expertise is not a role. It's if you have a colleague that has domain expert in their role, something is not right. You should be suspicious about that person. Anyone can be a domain expert because domain expertise comes from a lot of things: experience, interest about the domain, and a will to learn more and discover things about the domain. So you are probably domain expert, some of you, right? And if we turn this around, we can also, of course, say that anyone can have an opinion on the domain, but that doesn't make them domain experts, right? So the next thing, another cornerstone of domain-driven design, is ubiquitous language. What does it mean, ubiquitous? It means something that is found everywhere. And an ubiquitous language, then, it's a shared language. It's a language that contains the terminology that we use across the system. We have it in the user interface. We have it in our code. We have it everywhere. So that wherever you look in the system, you will recognize the language because it's shared. Now, I wrote system here. It's not really true because I talked about bounded context before. And in an enterprise, you have multiple bounded context. And within a bounded context, you have a domain model that models a particular aspect of the domain that is relevant. And the ubiquitous language applies within the bounded context. So if you have different bounded contexts in your enterprise, the ubiquitous languages will live in these contexts and can be different. There can be an overlap. You can have the same terms, client, for example, in different bounded contexts. But essentially, the terminology that you use within a bounded context is something that is sort of shared for that context. Now, of course, if we relate this to collaboration, you can imagine that having a ubiquitous language is very good for collaboration. The best way to hinder communication and collaboration is, of course, to speak different languages. So how do we enforce an ubiquitous language? Well, through collaboration with domain experts, and of course by speaking it, right? In the system, we used something called behavior-driven development. Anyone familiar with BDD? A few? Okay, great. So we used BDD as a way to sort of drive the collaboration between developers and domain experts. And with behavior-driven development, you express use cases, features, scenarios using a natural language. But it's not just any natural language. You express in your ubiquitous language. You focus very much on user value, and you involve the relevant stakeholders, meaning domain experts, meaning developers, and possibly other stakeholders that are relevant for you. What we learned is that everyone was interested. When we discussed the features and the scenarios, everyone involved was very interested in tiny details about the language. And I will show an example on the next slide. We also bridged a gap. Previously, it had been we and them, developers and requirements people, domain experts. And now we bridged that gap, so it was no longer we and them, but us. So an example. We have quite a classical example. It relates to what I had before about the ATM and withdrawing cash. So as a bank customer, I want to withdraw cash from the ATM so that I can get money off hours. And here we have a role. We have something that the system should be able to, a service the system should be able to provide, and we have a goal. And then we have a scenario. In this case, the scenario that there is enough money in the account. We said that given the customer has $100 and she withdraws $60, then there's $40 left, and so on and so on. And I've marked certain words here in green and red, and the green ones belong to sort of the BDD language, right? Given, when, then, and what you have up here as a I want, so that. But the red words are the words that we have from the ubiquitous language. And once we talk about this, we can get very interesting discussions. So when someone sees this, they can say that, well, customer is really not a good word to sort of represent what we have in our domain. Can we find something else? And then we can discuss that. And we can sort of dig into to details about the language. Now, if we just look from a domain-driven design and BDD perspective, this is just fine, because if we use BDD to sort of drive the collaboration between developers and between developers and domain experts, we've come a long way. But we can go even further. So what we have done here is that we have formulated scenarios, we have discussed concepts, we have really tried to set the or to establish the ubiquitous language so that everyone has a common understanding of what the language is. But then there are tools that let us run these scenarios as test cases, so that every time you check in your code, the build server will just run your scenarios and see if they pass or if they fail. And that is really cool, because the effect is that the domain expert will be able to look at the scenarios and say that, well, this scenario is green, so that functionality is okay, and this scenario is red, so there is something wrong there. So how many of you would say that you share your test cases with your domain experts? How many of you show your test cases to your domain experts? A few. But I think most of the time we have test cases in code. And code is something that we as developers like, but many people can't really make sense out of it because they're not developers. But in this case, we might have domain experts reading your test cases, and in some cases even perhaps writing test cases, formulating new scenarios, piecing together new things that can run as test cases in your system. So I have an example here. This is a tool called nbehave. I mean, there's very little from the tool here. So what we have is a number of methods, and these map to the sentences that we had on the previous page, given the customer has a certain amount in her account. And as you can see, there's something in the attribute up there. I have $amount. And what the tool does is that it matches the sentence from the previous slide against one of these strings in the attributes, and it extracts data from the sentences that match the variables I have up there and feed that data into the methods. So when the tool executes the scenarios, it will execute these methods and feed data into them. So in the given method, I can say that I set the balance to that amount, but in the withdraw step, I use what you saw before. I say withdraw and this many dollars. And then in my then step, I can say, then I can assert that the balance on the account is what is expected from the step. And then, of course, I can have much more that checks for some sort of event that relates to dispensing money and printing a receipt. And if you look at different tools, typically you have regular expressions that you can use to match to the text. In this case, it's a simple model where the tool would just look at these variables I've marked in red. And we use this very successfully. And the result is that you don't not only have features and scenarios that describe your system, but you can actually go down in the code and see that you use the same language, use the same terminology really across the system. And once you have this, you can then unit test, drive your code, and let this sort of be a way into coding something that is extremely close to the discussions that you have with your domain experts. All right, so I have a couple of minutes left. I have some slides that I'm going to skip. It will take too much time to talk about those. Let's see if I can just go past this. And wrap up. So what we did was create a system that was extremely simple compared to what the client had before. It was tiny compared to other subsystems, and the reason it was tiny was, among other things, that we chose to only use as few layers as possible. We got rid of a lot of ceremonial code. We didn't use a lot of the frameworks that were in place, and as a result, we could get away with just as little code as we needed to implement the functionality. And instead of using the standard approach, big architecture, driving the size, we created something tiny that we could that was exactly what we needed, tailored for the problem. We had a rich domain model in focus, so compared to the previous situation where all the domain logic would exist in services, we would have all the domain logic, the business rules, everything in the domain model, and the services would be very thin. We had a system that was very well tested. As I said before, the standard way the client would build software, the standard architecture they would use, didn't really lend itself well to testing, to automatic testing. So by moving things into the domain model, we could have a situation where we had everything very well tested. And we saw excellent performance when we benchmarked compared to what the client had before. So what I talked about during the session is the domain model and what a domain model is and how you should focus on the domain model, because the domain model is where you can get sort of the most value out of your business, and it's what sort of endures. As opposed to mechanisms around that sort of follow trends and can be changed. I've talked about a number of patterns, tactical DD patterns such as aggregate, value object, and repository, and how we use those. I've talked about creating simple solutions and choosing solutions that match the current knowledge level that you have in your project. So instead of starting with big complex solutions, start with simple and grow as you learn more. Domain expert collaboration, very important. Evolve your domain experts. Talk to them all the time so that you sort of get new insights about the domain, that you can incorporate new knowledge into your domain model, and so that you're on the same page with what you're building. Do that through a ubiquitous language so that instead of developers talking about their stuff, code, classes, talk the same language as the domain experts do, and you will be able to communicate very effectively. We challenged the development habits. We built something that was very much different from what the client had before, and the result was very good. Excellent, actually. So with that, thank you very much for listening. I can take any questions now.